Hi friends, taking a look at lesson 10 today. We're here in unit 2, lesson 10, talking about multiplicity. Now this one does have a notice and a wonder as we start working on this, since I'm not there to kind of help facilitate, but there might be a question there for you to answer on the Google Classroom or on a forum. So check there if that's in your instructions to answer what do you notice and what do you wonder. If you'd like to pause this, you can certainly take a look at that and analyze a little bit of what you notice and wonder before I start even talking further. Some things that I notice and wonder is, first of all, that I'm going to make the connections of each of our factors and how they turn into zeros. We've seen this throughout our unit so far. So I see that I'm going to have each of these factors turning into a zero. This one would have two zeros, one at x equals -1 and one at x equals +3. This one looks like it just has, again, still that 0 at x equals +3. And this one's got it at +3 and +6. So I'm noticing a lot of the factors and the zeros that we're used to, but I see some interesting things start happening on the graphs. And it's because we have these duplicate factors. That's what's telling us multiplicity. Multiplicity just means that we have a single factor, which we also know is a zero of the equation, or an x-intercept. Happening many times. All right, and so we're trying to figure out how many times that single factor happens. And it has something to do with the degree, or the exponent, on that factor. All right. Now we have, in this case, something that's just a degree of 2. It's got 2 parts to it. It's hitting that 0 at +3, so I expected that. That's something that I do definitely notice. And I see that it's kind of got 2 branches or 2 parts of it that are coming to meet here. It's almost like this one's meeting this way and this guy's going that way, and so it's hitting there twice. This kind of makes a bounce on the graph. I like to call it that bounce because it hits the x-axis. It does touch the x-axis, and then it bounces right back up to where it came from. And on our one right next door, I noticed that same kind of bounce happening here because this graph has a multiplicity. This 0 has a multiplicity of 2. It's happening twice. So we're getting the bounce there at +3. And this one doesn't have an exponent up there. If it doesn't have one, we just assume that it's 1. So this one is just going straight through the x-intercept at -1 right there. So something that we can say is that it is the degree on each factor and it tells us a couple things, right? It's going to tell us how many times that factor happens. And when we're looking at the degree of a polynomial, we would have to look now at all of the degrees on each factor. So this guy, looking at even our end behavior and what our graph would be looking at, it has a degree of 3 total, 2 here and 1 here. So it's got a degree of 3. This one has a degree of 2. So the degree on each factor tells us how many times that same 0 happens. It also is going to be telling us the shape of the graph at that point. Shape of the graph at that 0. So a degree of 1, it just goes straight through. is just a line that's just passing straight on through there. If it's a degree of 2, or 4, or 6, or 8, even, we're going to see a bounce. And the more that we have on top of each other, the kind of the longer that bounce is going to go, right? So it's coming here, and this one's just only hitting twice, so it's going to do a quick bounce right on up there. I'll show you what I mean by that in just a couple minutes. Something to the third, it doesn't just go straight through at 3. It doesn't bounce and then go back the way it came from. This one kind of goes here and it hits a little stutter. It kind of pauses, right? You see how it kind of goes horizontal? And then it goes back in the same direction that it was heading anyways. So it looks like a third degree polynomial is just going to take a little pause there. Okay, so it's going to do a little pause. And again, this is for degree of 5 and 7 and 9. The more we have, the longer that horizontal pause is going to be. So it does a pause, or I don't know, what should we call that? A little plateau? And we see that the bounce can happen from the bottom. The bounce could happen from the top and go back up to the top. The plateaus could keep on going. So it's all a matter of also what the rest of the graph is doing, which is why we need lessons 8 and 9 first, so we can think about end behavior and where these graphs are going to in their endpoints. All right, so this guy has a degree of 3, one factor happening 3 times. So this x equals 3, 0 is happening with a multiplicity of 3 because of that exponent. Here our x equaling 6 has no multiplicity, or we could say a multiplicity of 1. Our x equaling 3 has a multiplicity of 2 because of the degree. It's happening twice, and they're happening like right on top of each other. Okay. And I mentioned that the higher that degree is, kind of the longer that pause, or that if we're doing a plateau, or kind of the wider that bounce gets. So I just want to show you a couple examples of this here, and then we'll move forward. So if I do something as simple as like x squared, oh yeah, let's make that an exponent. We're going to see a graph, and then I'm going to go to an extreme. I'm going to show you what x raised to the, let's go for something even numbered, like 48. All right, we're going to take a look at what these graphs are looking like. So here comes my first graph. That's the one that's just doing a quick bounce. And then our one at 48, let's see what that looks like. X to the 48th power. It's still thinking. It's still thinking. There it is. Whoa, that looks so cool. I'm going to zoom in just a little bit. So here's our one that just did a quick bounce and then headed up there. And then our second one that's going to come in that had 48 zeros right on top of each other. Look at this. Do you see how it's coming down and just kind of totally hanging out there for a while and going up there? That's what I'm talking about. So the higher the degree, the longer that pause is going to be. Same thing holds true when we're looking at something like up to the third. So I'll do my x to the third. I'm going to do a number not quite so big this time, maybe just to the 21st, and let's see what that looks like. Okay. So x to the third, there it is, comes up and does that pause. X to the 21st is going to come up, and you see how it's got that same thing where it's doing this longer pause. It's hanging out there for a while because it's got 21 of them right on top of each other right here. Okay, now it doesn't mean that we have all of these zeros at like 0.5 or 0.7. It looks like it on the graph. If I were to trace it, we can see that even when I go off there, it's the tiniest little itty bitty decimal. So it's just barely a y value that's up off the graph. So it takes a long time for it to get moving again. When we start looking at these, we have just a lot of practices, and I may not work through every single one of these, but it's going to ask us to sketch polynomials with the degree, the zeros, complete the sentence about the end behavior, sketch a graph, check your graph, pause here to check the work. Whew. It's a lot of stuff going on here, but we're going to go step by step like we know how. Each one I'm going to try to go in the same kind of pattern, so we kind of go step by step in looking at these. And this is what we'll definitely have some quiz questions or test questions coming up about this exact stuff, kind of pulling it all together here in lesson 10. So I start by thinking about the degree. Each factor that I see has a degree of 1. And if I multiplied all of this out using my polynomial multiplication, the grid multiplication, I would also see that I would have an x to the third power. So this has a degree of 3. Each factor happens one time. The zeros that I see happening, I'm going to quickly just be turning each one of these into its set of zeros that we have. Remember, we can do each of that by setting it equal to 0 and solving for x. So I'll subtract 2 from both sides and find out one of my zeros happens when x is negative 2. It only happens one time, so I'm just going to leave it kind of like that. There's a 0 at negative 2. It only happens one time, so I like to remind myself there's going to be like a little line there. Okay, so just a straight line happening here at negative 2. I have another 0 that's happening at a positive 2. Again, I know that if I were to set it equal to 0 and solve for x. But I know 2 minus 2 equals 0, so positive 2 is what would make that happen. There's our 0 there at positive 2. And our last 0, x equals 8. We have all of our x-intercepts. I have a degree of 3. And if I were to multiply all of my x's out, there's no coefficients, there's no negative symbol, there's no anything at all like that. So this would be looking at an x to the third, and it's a positive leading coefficient, x to the third. So that positive tells me it's going to end going upward. Odd degree tells me on the left side it's going opposite of that right side. So as x gets larger and larger in the negative direction, remember what that's saying. Really, let's just think about end behavior. We can even cross all this stuff out. It's going to be down on the right side and up on the left. And I actually put some arrows like that kind of on my endpoints just so I kind of remember what that looks like. Okay. Now the last thing that I also want to know in order to make as accurate a graph as I can is the y-intercept. Now we would normally find that if this was in standard form by looking at the constant. But I can also find that when x equals 0. So when I put in 0 for each one of these, I would have a 0 plus 2. I'm putting it in for every x. 0 minus 2, 0 minus 8. And we're multiplying all these in together. 2 times negative 2 times negative 8. 2 times 2 is 4 times 8 is 32. And positive times a negative is a negative. And that negative times another negative is a positive. All right, so I know it's going to have a y-intercept at positive 32. And because each one of these, oh, I didn't label, sorry. Every single one of these zeros just has a multiplicity of 1. They're all just going to have a line going straight through. So here's what my graph might look like. It would go straight through. I know it's got down end behavior, so it's going to be working up from there through -2, up to 32, turn down to go through that 0 at +2, and then somewhere down there it's going to go back up through 8 to hit my upward end behavior. So that's what that graph would look like. I could check it out on Desmos, so I could put that in and I could see that same thing. Now our second one here has a degree. Let's see. One factor is happening one time. This factor is happening 2 times. So it's like having x plus negative factor x plus 2, factor x minus 2, and another factor x minus 2. That's what that squared means. It's happening 2 times. So I could multiply this all the way out into standard form. We've got that skill. I'm not going to practice that here. But this is telling me I have a degree of 3. So I'm going to look at every single one of my factors and turn it into a 0. Our x plus 2 factor is going to have a 0 at -2. It's only happening one time, so it's going to have a line there through -2. My next 0 here at +2 has a multiplicity. So I'm going to mark that here. It's got 2 with a multiplicity of 2. It's happening 2 times. I'm going to have a bounce on the graph here at 2. So I go for a 2. I'm going to put a B there for a bounce. Okay, so that's just my little reminder. This one's going to bounce. I don't know if it's going to bounce from the top and back up, or if it's going to bounce from the bottom and go back down, but it is going to hit that axis and then bounce away. What's going to help me figure that part out is my end behavior. It's going to be helpful for that. If I multiplied all of this stuff out, I would have a negative x times x times x. A negative x to the third. That negative leading coefficient tells me where my graph is going on the right side. Remember, the beginning leading coefficient tells me where my graph goes at the end. So it's going to be down on the right side. Man, I just realized I put that backwards over here. So sorry. Gotta correct myself before I go on. Hopefully you have an eraser and you can see that. I just got my lefts and my rights mixed up. It's very much going up on the right side, down on the left. I had my arrows in the right place. I just wrote it incorrectly there, so I'm sorry about that. Quick fix. So this one goes down on the right side. Leading coefficient tells me where it's going to end here on the right side of the graph. That opposite odd degree is telling me opposite on the left side. So we have an up, down, up on the left, down on the right. And the last thing I want to know is what happens when I put in 0 for x to find that y-intercept. I've got lots of space down below, so I'm going to do this. When x equals 0, I have negative 0 plus 2, 0 minus 2, 0 minus 2. So I put my x into each one of my factors up here, or I could have put it into this one and then squared it. What I have is negative 2 times a negative 2 times a negative 2. Negative, negative, negative is going to be a negative value. Negative times negative is a positive, but I got this third negative. That's going to make it that way. 2 times 2 is 4 times 2 is 8. My y-intercept is happening at negative 8. And so I'm ready to graph through this now. My end behavior tells me where to start. It's going to cut through at -2, go straight through because I don't have any letters there to remind me. Cut down through -8, come back up from the bottom, and here's my B to remind me bounce. I'm going to hit it and bounce down. And that's what our graph is going to look like. Lots of practices here. Whole page full of practices. So we're going to keep on following each of these things. I'm going to keep on going just a little bit faster each time. Degree of 1 and 2, third degree. Zeros happening at -6. The line's going to happen there at -6. Next zero is happening at -2. It's got a multiplicity of 2. I got a bounce. At -2, I have a bounce to this graph. X times X times X is going to be a positive leading coefficient to the third. My end behavior, it's going positive on the right side. It's going to be going up on the right. Odd degree, opposite end behavior, down on the left. Plug in 0 for X to find my y-intercept. It's happening up here at a positive 24. I'm ready to connect the dots. Straight through at -6. Turn around somewhere and bounce it down at -2, up through positive 24, and on forever and always. You can always pause this video and try to work ahead of me, see what yours looks like, and then try 1 or 2 of these ahead of me and check your work as we go. So feel free to hit pause, and then you could watch it pretty fast. I keep on going a little bit faster each time looking at it. I've got a degree of 2 and a degree of 1, so I have a total degree of 3 happening. My zeros that are happening are -6 with a multiplicity of 2. I can tell that because of the degree, the exponent here on this factor of x plus 6. I know my other zero is happening at a -2. It's going to just have a line. So -2, straight through with a line. -6, multiplicity of 2. It's going to have a bounce off that graph right there. Thinking about end behavior, I have a -x, x, x. Okay, remember there's 2 of these x here, the x plus 6 squareds. Okay, keep that in mind. -x, x, x is telling me a -x to the third power. Negative leading coefficient tells me where this graph is ending over here on the right. It's going to be going down on the right side. Odd degree, opposite end behavior, up on the left. And I feel like all of them have been odd degree. Make x equal to 0, plug it into the equation, and let's find out what our y-intercept is. Don't forget the squareds and the negative in front. -72 is my intercept. Ready to connect the dots. Starting from our end behavior, come on down to hit that 0. Oop, it's got to bounce. It's going to bounce up here. Somewhere it's going to turn around, and it's going to go down straight through -2, down through our y-intercept at -72, and go down and down and down forever for our end behavior. E. Degree of 1, degree of 3, total degree of 4. There's my even end behavior I was looking for. 0 is happening at -4. There's our first one, happening one time, line straight through at -4. Next 0 is happening on this factor at a +2. With a multiplicity, this time it's happening 3 times all on top of each other. That 2 is going to happen here. This is going to have a pause, right? A pause or a plateau. That's what I'm going to put a P there for. It's going to kind of get there and sit there for a little bit and then go in whatever direction it was starting in. End behavior. X, 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 X. I have one X here. I have 3 x's that would multiply here, x to the 3rd. I have a positive x to the 4th. There's our degree, our positive leading coefficient. Positive tells me up on the right. Even degree, equal end behavior, up on the left. Up, up, end behavior. Y-intercept, plug in 0 for x. 0 plus 4 to the 1st power, 0 minus 2 to the 3rd power. Always okay to use a calculator here. I'm going to use it here just so I can make sure you guys can see that I'm doing that too. No biggie. Calculators are here to help. I put that -2 in parentheses just like that. Boom, -32. Y-intercept, constant of our equation at -32. I could tell that too. If I multiplied this all the way out into standard form, I would know that as well. Ready to connect. Straight through -4. Up through -32. Take a little pause here, so I'm going to do a quick pause to show that, yep, that's going to slow down a little bit and then it's going to continue on its way. So it doesn't have to be a super big pause or wiggle there, but something that just kind of says, hey, whoop, multiplicity, before we move it on. One last one, I think, and then you can write your own and test it out or try some different things going on here, but this is our last guy, so hang in there with me. I see a degree of 3, a degree of 1, a degree of 2. So 3 times, here's another 4th, another 5, 6. This has 6 degree of 6. I mean, my end behaviors are going to match. I'll think about that in a second. I see our first factor, that x by itself is telling me that I have a 0 at 0 with a multiplicity of 3. So a 0 here at 0 with a pause happening. I have a 0 at -4. It's got a multiplicity of 1. I don't got to worry anything at all about that one. I just have to make sure I plot it on my x-axis. And my last 0 at +3 with a multiplicity of 2. That tells me at this 0 here, I'm going to have a bounce. So a pause here at the origin, a bounce here at 3. Every x is positive. I have no leading coefficients in the front, so I just have x to the 6th power. It's a positive leading coefficient. It's going to be up on the right. It's going to be up as well on the left because it's an even numbered in our degree. Up, up, and behavior. When x equals 0, I will have an ordered pair at 0. Let's see, 0 to the third power, 0 plus 4 to the first power, 0 minus 3 squared. 0 times 0 times 0 is 0. 0 plus 4 is 4. 0 minus 3 squared is a negative 3 squared. Doesn't matter what these numbers are actually at this point, right? Because negative 3 times negative 3 would be 9, times 4 is 32. It's all, doesn't matter, sorry, 36. None of that matters though, because it's multiplying by a 0, so my output will be right here at the origin. I actually could have seen that, the fact that I already had it right there at the origin for the 0. But it's nice to be able to calculate that. Let's connect the dots. From my up and behavior on the left, I'm going to go straight through negative 4. Pull a U-turn somewhere and come up to that origin and hit a pause right there at the origin. Then I'm going to come up a little bit. I got to get a bounce on this next guy, so I got to hit our 0 here at 3, bounce right back up, and there we are. Remember, you can always check any of these on Desmos or on a graphing calculator. So this is a great one. End it off. Let's just take a quick look at what it looks like in a graphing calculator. X to the third, x plus 4. Remember our x button, ooh, it's right under where I'm using. Right there is our x's as we're putting those in here, and our y equals to graph. Our x plus 4 is to the first power. I don't have to do anything to that. Last but not least, x minus 3, and raise that to the second power. There's our graph that matches here. Here is what our graph should look like. Ooh, it dips way down. Cool. All right, I got all those good things. So it went down through negative 4, dipped down, came here, did that little wiggle at the origin, went up, came down here, just bounced right off at 3, and then continued on forever. Some great looks at a lot of different graphs. I hope you slowed that down or tried some on your own. You can then start creating some graphs to hit some representations. So sketching a graph for a polynomial function that has 3 different zeros, and our function is greater than 0 for all values of x. Whew. Some pretty interesting stuff going on there. So we could put our 3 zeros wherever we wanted to. But if all of our values are greater than or equal to 0, all of our outputs, the entire function, it's telling me that no matter what, it can't go below the x-axis. So it could look something like that. Now this means I've got 3 different zeros. So a factor at x plus 8 in my example, x plus 2, and x minus 6. I just turned each of those zeros into a factor, but every single one of them has a bounce. So every single one of them would have to have an exponent of 2 or 4 or 6 or 8. The smallest degree that this polynomial could have is a degree of 6, because it's got to have 2, 4, 6 degrees there. All right. So a possible equation for the polynomial, boom, I just wrote that one right there. All right, and it says use some graphing technology to see if your equation matches your sketch. Okay, you want to see it? I want to see it too. X plus 8 squared, x plus 2 squared, x minus 6 squared. Let's see if it matches something somewhat of my graph. Well, that doesn't look quite right. It's pretty funny. I'm going to try to change some of my window settings because that just seemed pretty odd. That's so weird that it's not showing it come all the way down. I couldn't tell you why it's doing that. I'm sure my decimals would actually look a little bit better. But it's showing me my zeros are happening right there, right where I'm thinking of. Now I gotta go check on Desmos because I want to know what this thing's looking like. Let's pull open a Desmos screen. I had an x plus 8 squared. I had an x plus 2 squared times x minus 6. Big surprise, it's squared. Projector mode. Can you see that all the way through? I'm not sure if you can. Alright, so I'm going to zoom this thing back a little bit. I can definitely see it hitting where I need it to there. If I spread this thing out a little bit, I don't want to see any taller necessarily, but I do want to see things a little more spread out, a little bit wider. So I'm going to go from -9 up to maybe just, what's my highest one? 6. So let's go up to 7. Ooh, man, I gotta have a heck of a screen in order to see all this. That's pretty weird. You see how I put mine up to like 100,000 and now I can see that wiggle going for the graph that I drew. Kind of weird, kind of wacky. All right, lots of fun. Thanks for checking that out. When we do go back to our workbook, you'll see in our summary, it does remind you that when we have each one with a multiplicity of 1, it's just going to be a line going straight through at that 0. When I have a multiplicity of 2, we're going to have a bounce happening. So when we zoom up, we'll see that bounce. And a multiplicity of 3 happen in here, where we're going to see it hit that little pause and continue onward. All right. Thank you, friends. Watch this video again. This was a lot of information that brings all of our thought processes back together into a single place. Try out some of these graphs. Check them out. Do them 2 or 3 times. Hit pause again. Rewatch if you need to. All right. Please make sure you take care of practice 10 practice problems. Lesson 10 practice problems.